Hello. Yeah. Hello everyone. My name is Urvi Singhal, a core committee member at IEEE-WIE, and I welcome you to today's webinar on building a movie recommendation system using Python. Thank you for taking time out and being here today, and I hope that you find the session interesting. While machine learning seems like a daunting, fascinating field, it can be a little daunting to know where to start. Thus, IEEE-WIE brings to you a two-part series to help you in your journey. To know all about the different algorithms of machine learning, you can watch the first part of the series called the Backbone Algorithms on our YouTube channel. This brings me to the next part, making a complete project using machine learning. Now, without further ado, let's begin with our session. So this is the flow of the event. First, I'll give an introduction of ML. Then we learn about the different applications of machine learning. Then I'll discuss about the project. After that, it will be the I'll explain in brief about the different libraries and tools I've used. And after that would be the practical demo of the project. So the question is, what exactly is machine learning? In layman's terms, machine learning can be defined as the ability of a machine to learn something without having to be programmed for that specific thing. It is the field of study where computers use a massive set of data and apply algorithms for training themselves and making predictions. Training in machine learning entails feeding a lot of data into the algorithm and allowing the machine itself to learn more about the processed information. ML has proven valuable because it can solve problems at a speed and scale that cannot be duplicated by the human mind alone. With massive amounts of computational ability behind a single task or multiple specific tasks, machine can be trained to identify patterns in and relationships between input data and automate routine processes. For example, in 2016, the strongest Go player, Lee Sedol, competed against Google DeepMind's machine learning program, AlphaGo, and the result of the 5-day long match was that AlphaGo won. Now, machine learning isn't just useful for winning strategic games like these. Do write in the chat what you think are some applications of ML in our daily life. Now, let's move on to the applications. Banks, trading brokerages, and fintech firms use machine learning algorithms to automate trading and to provide financial advisory services to investors. One example of these services is the use of chatbots for automating services. It is also being used in the banking sector to autonomously analyze large numbers of transactions to uncover fraudulent activity in real time. The next is definitely my favorite application. Ever wondered how exactly self-driving cars, such as those of Tesla, work? Well, the answer is once again machine learning. Tesla uses unsupervised learning method to train the car models to detect people and objects while driving. Even in healthcare industry, ML plays a vital role. It would be next to impossible for humans alone to analyze the massive healthcare data sets, and thus ML speeds up this process in order to discover newer treatments and cures, improve patient outcomes, and automate routine processes to prevent human error. The final application we'll be discussing today is the use of ML in retail and entertainment industry. Isn't it curious how Netflix or Spotify always, or well, almost always, manages to recommend something that perfectly matches our mood? Or how Amazon displays things on homepage that we were just thinking of buying? The way it works is by using a special type of ML model called recommendation systems. We will go into more detail about them, but before that, do tell me which application fascinates you the most. So this brings me to the topic of today's session, that is building a movie recommendation system using Python. Now, what exactly are recommendation systems? And for people who might have studied ML before, do you know the different types of it? The basic concept behind a recommendation system is quite simple. In particular, there are two main elements in every recommender system, user and items. The system generates prediction for its users, while items are the things being recommended. The primary goal of recommendation systems is to filter and predict only those movies that a corresponding user is most likely to want to watch. The ML algorithms for these recommendation systems use the data about this user from the system's database. This data is used to predict the future behavior of the user concerned based on the information from the past. Movie recommendation systems can broadly be divided into two categories: content-based and collaborative-based systems. In content-based filtering, data plays a crucial role and is extracted from only one user. The recommendation system analyzes the past preferences of the user concerned, and then it uses this information to try to find similar movies. This information can be in the form of lead actors, directors, genre, etc. After that, the system provides movie recommendations for the user. Whereas in collaborative filtering, it is based on the combination of relevant users and other users' behaviors. The system compares and contrasts these behaviors for the most optimal results. Suppose A liked movie 1 and 2 and B liked movie 2 and 3. As both of them have movie 2 in common, the system would then recommend movie 1 to B and movie 3 to A. The mixture of both these type of filtering is called a hybrid-based recommender, and for today's project, we will be using that. Now, before starting with the project, let me just explain the different tools and libraries used. Pandas is a Python package that is mainly used for data analysis and associated with manipulation of tabular data in data frames. NumPy, which stands for Numerical Python, is a library consisting of multidimensional array objects and a collection of routines for processing those arrays. Using NumPy, mathematical and logical operations on arrays can be performed. Both matplotlib and seaborn are Python libraries used for data visualization and plotting graphs. Word cloud is also a library used for data visualization in the form of word clouds. The literal eval function from the AST can safely evaluate string containing Python values from unknown sources without us having to parse the values. Now, I'll explain the others in more detail. First is the count vectorizer. Text data requires special preparation before you can start using it for predictive modeling. The text must be parsed to remove words, and this process is called tokenization. Then the words need to be encoded as integers or floating point values for use as input to a machine learning algorithm, and this is known as vectorization. Count vectorizer is a great tool provided by the scikit-learn library in Python. It is used to transform a given text into a vector on the basis of frequency or count of each word that occurs in the entire text. Count vectorizer creates a matrix in which each unique word is represented by a column of the matrix, and each text sample from the document is a row in the matrix. The value of each cell is nothing but the count of the word in that particular text sample. Suppose we have a sentence, I like apples. Inside Count Vectorizer, these words are not stored as strings. Rather, they are given a particular index value. In this case, apples would have index 0, I would have index 1, and like would have index 2. Then the values under these would be the occurrences of each word in the given text. Does anyone have any doubts till now? Okay. Next is the cosine similarity. Recommendation systems work based on the similarity between either the content or the users who access the content. Cosine similarity is a metric used to measure how similar two items are. Mathematically, it measures the cosine of the angle between two vectors projected in a multidimensional space. The output value ranges from 0 to 1. 0 means no similarity, whereas 1 means that both the items are 100% similar. So we use this to find the similarity between the vectors we get using count vectorizer, and then use that to judge the similarity between the movies. This, along with count vectorizer, is used to build a content-based filtering system. Now, SVD, or singular value decomposition, is a matrix factorization technique which reduces the number of features of a dataset by reducing the space dimension from n dimension to k dimension, where k is less than n. In the context of the recommender system, the SVD is used as a collaborative filtering technique. It uses a matrix structure where each row represents a user and each column represents an item. The elements of this matrix are the ratings that are given to the users. Thus, we can use SVD to derive relations between the users. Now, instead of building a SVD model from scratch, we can make use of Surprise. Surprise is an open source Python library that makes it easy for developers to build recommender systems with explicit rating data. In order to train recommender systems with Surprise, we need to create a dataset object. A surprise dataset object is a dataset that contains the following fields in this order: the user IDs, the item IDs, in this case the IDs for each movie, the corresponding rating, usually on a scale such as 1 to 5. Now that this is done, let's get to the practical part. I will be using Google Colab and I'll paste the link for it in the chat. Colab is a free Jupyter notebook environment that runs entirely in the cloud. Most importantly, it does not require a setup and the notebooks that you create can be simultaneously edited by your team members. This is an incomplete notebook and we'll be completing it during the session, so do follow along. Um, just a second. Um, yeah, the link should be in chat. Can you guys see the link? Okay, yeah. Is my screen visible for everyone? So now that we have our notebooks open, you all can just save a copy of it in your drive because you won't be able to edit this one. So just tell me after you're done with this. Just go to File, Save a copy in Drive. Okay, now let's start with it. The first step is to import the necessary libraries. Also, we need to install Surprise using pip. I'll send the now let's run it. Just run the first two blocks. Has it run for both? Has both these codes run for you guys? Okay, now that this is done, the next step will be to load the dataset. The dataset I am using is the small movie dataset from Movie Lens, which contains the data for 9,000 movies. It was last updated in 2018, so it doesn't contain the movies after that. I've also preprocessed the dataset and will be using that for this session. I've uploaded the dataset to my GitHub. Also on Colab, you can load the dataset in multiple ways. I just like to upload it to GitHub and then use it from there as it is pretty convenient. Just remember that for using dataset directly from GitHub, you need the URL of the raw dataset. I'll send these after everyone has done these steps. Just message in the chat. Now let's run these. Okay. The next step is EDA or exploratory data analysis. In this step, we analyze the dataset and try to get inferences from it as a preliminary step. I won't go into much detail, but I'll teach you the basics. So first, let's look at the first 5 rows of the movie dataset. For that, we'll use the head function. Notice how it has different columns. Just explore it a bit. So we have a column for adult, belongs to collection, budget, genre, homepage, ID, IMDb ID, the language, title, overview, and many more. Next, we use the info function to check some more information about the dataset. Notice how it shows you the total number of columns and the number of rows. Suppose 9219 rows and 32 columns are there. It also shows the number of values in each column. Suppose see this belongs to collection has many missing values. It also tells you the type of that column. Next, we'll create a word cloud that would show us the most used words in the movie titles. For that, first we'll convert the objects in original title column to strings. Then we'll just create a text chain with all the words in it. Let's now plot the word cloud. Notice how words like love, man, day are pretty prominent in it. This means that these words are the most used in titles. Is everyone able to follow? Is everyone able to follow along? Or do I need to scroll or something? We have just added the head function and the info function. Next, let's sort the movies according to their budget. We will display the title, the budget, and the year it was made in. Notice how Pirates of the Caribbean on Stranger Tides have the highest budgets of 32 crores. This was made in 2011. After that was Pirates of Caribbean at World's End. That had a budget of 30 crores. Now let's explore the other datasets a bit. First, we will look at the links dataset. So this has three columns: movie ID, IMDb ID, and TMDB ID. Let's look at the info for it. There seems to be some missing values in the TMDB ID column. Similarly, let's look at the ratings dataset. It contains user ID, movie ID, rating, and timestamp. Now describe is another function which gives us information about the dataset. Let's try using it. See how it shows us the count, mean, standard deviation, minimum value, maximum value, and such. So notice there are maximum rating given to any movie was 5 and the lowest rating given to a movie was 0.5. So we can use these methods to infer different knowledge about the dataset. Shall I move on to the next section now? Okay. So the next step is to build the model. We will use count vectorizers fit.transform to count the number of texts, and we will print the transform matrix, that is the count matrix, into an array for better understanding. When we pass the text data, in this case the soup column through the count vectorizer function, it returns a matrix of the number count of each word. Before that, we can just look at what the soup column contains. So, so it basically I just added keywords, director, actor, and such important data. All the keywords in those in one single column, so that we can use this data for our prediction. Now let's run this one. Then we will pass the matrix through the cosine similarity function to get the similarity between them. Now let us initialize Expedia and Radar. We will now load a dataset and then cross-validate it. Cross-validation is a technique for validating the model efficiency by training it on a subset of input data and testing on previously unseen subset of the input data. For checking the accuracy, we will be computing RMSE, that is the root mean square error, and MAE, that is the mean absolute error. This will take a while to load. So till then, do any of you have any doubts? Are you able to follow along or should I slow my pace a bit? Okay, yeah, this is done. So notice we get a RMSE of like mean RMSE of 0.896, which is pretty good. So we can go towards fitting our model. We're just gonna fit the training data. Okay, that's done. Now let's check the rating. This shows us the different ratings the user with the ID1 has given to different movies. So notice how all of them are different. I'll explain this function in a bit. Let's go to the next part. For this, we'll create a new dataset that just contains the movie ID and the TMDB ID. Okay, done. Let's have a look at this dataset. So yeah, it contains just the movie ID and the TMDB ID. Remember how that TMDB ID column had some missing values. So now we'll rectify that. So to rectify that, we're going to pass all the values through the convert int function that we made earlier. What this will do is convert all the values to int, and in case of missing values, replace them with nan. That is not a number. What this does is solves the problem of missing values and makes our dimension uniform. So we'll just run this code. Oh wait, I forgot to run this. Yeah. Okay, this is done now. Let's see what this changes. See how now there are no missing values. Also, we have merged this new dataset we created with the movies dataset on ID. So it just and we have renamed TMDB ID to movie ID for convenience. Now let's create the indexes for the movie. Okay. In this, we have just created a series that contains all the movies with their indices and a data set that has the ID index, has the ID as the index. I'll just show them to you. Indices. So see how it's just a title index with all the movies and a number next to them, which we will later use. Also the indices map. dot net. So it contains the ID column as the index, and next to the ID here is the TMDB ID, and next to that is the movie ID. Okay, so this is our main function. So cosine sim variable we defined before is the matrix of similarity coefficients. Row 1 of that matrix should provide the similarity coefficients of all the movies with, suppose we take, this takes two inputs, a user ID and title. Suppose our input for title is Jumanji. Let me just show it to you here. See how Jumanji has 1 next to it, the index 1. So it would just, the IDM variable would just search for that title in the indices series and give the number to that. So for Jumanji, the value of IDM is 1. Next, the TMDB ID variable is just finding the movie with that title in that DF dataset and giving us the ID for that value. And same for movie ID with the movie ID of that value title. Next, in sim scores, cosine sim variable we defined before is a matrix of similarity coefficients. Row 1 of that matrix should provide similarity coefficients of all the movies with Jumanji. I am using enumerate to get the index and coefficients of and the coefficients. Sim scores is a list of tuples that contains index and coefficients. Next, we will sort the list sim scores by the coefficients in the reverse order. That way, the highest coefficient will be on top. We will just We will just take the first 25 values in the list. Next, to get the movie indices, we will take the values at the zeroth place. Thus, movie indices is a list of all indices of movies that are similar to given movie in order of most similar movie first. Now that we have our top 25 movies, we will create a new dataset called movies, and in that we'll display the title, vote count, vote average, year, ID of the top 25 movies. We'll then add a column called est, which is the estimated prediction we get on using SVD. Then we sort the dataset according to descending values of EST column. At the end, we'll return the top 10 values in the dataset. So let's try out this function. I just run this and I will, let's choose some movies. Let's go with Jumanji only. For user ID, I'll just take uh, 5 and title is Jumanji. Jumanji. So this has given us the recommendations. So for the user with the user ID 5, the movie with the highest recommendation is October Sky, then Harry Potter and the Half-Blood Prince. After that, Harry Potter and the Deathly Hallows Part 1. So let's check it for some other user. Suppose we check the user with user ID 10. Have to change it. Okay. Uh, Did you notice how Peter Pan was fourth for the 10th user and now it's in the fifth place? I'll just do it again. But the first three movies have remained constant for all the users. So these are pretty similar to Jumanji. See, the Peter Pan and Captain America have interchanged positions. Let's try for some other movie. Suppose, what are the movie names? Let's try for Toy Story. These are the recommendations for Toy Story. First is Toy Story 3, then Monsters Inc., the Lego Movie, and so on. Let's check for some other users. Let's check for user number 1. For him, Monsters Inc. is first. So, as you can see, our model gives us recommendations different for each user. Does anyone have any doubts till now? Also, feel free to experiment with this notebook on your own, like try different movies, different users, and see what predictions they give you. We can try for other movies also. Let's see. The Grumpier Old Man. Okay, so for this, Shirley Valentine is the first entry, then Turtle Diary, then Bye Bye Birdie. Okay, now that this is done, I'll share the code for the completed notebook with you later. Now that we're done building a recommendation model, the next step would be deployment. The easiest way to do that is to deploy them as web services. You can do it by creating a REST API using Flask or by using Streamlit and then later host it using Heroku or Streamlit Share for free. There are many resources for deploying, but deploying requires changing some, adding some change, doing some changes to your model. So you can search a bit more about that if this seems interesting. That's the end of our session. For any doubts, feel free to connect with me on LinkedIn. I'll send the link to that in chat along with my GitHub. I will be uploading the whole code to that, so if anyone missed anything, they could refer to it. I hope you enjoyed the session and learned something new. Thank you for being a part of it. Feel free to experiment with the notebook and try different things. I'll just send you the links. Once again, I'm so happy that you guys attended the session and just hope that you found it fun. Feel free to message me regarding anything and any doubts you have. Thank you.